So one is your Darlington pair. Okay, Darlington pair. So what is Darlington pair? So they are basically two coupled transistors. You have two transistors, okay, coupled to each other. So the emitter of one transistor is connected to base of another transistor. So this type of configuration is basically used, okay, to enhance the amplification factor beta. Okay, so you have two transistors. Okay, you have, this is your VCC. Okay, this is your base terminal. So now what happens? Okay, you have current IB1 here. Okay, the amplification factor, the gain factor, current gain is beta 1 for this transistor, and for this transistor it is beta 2. Okay, so this current is coming, which is your IE1. Now IE1 becomes base current for this transistor IB1. Okay, now automatically when you come from here, you get current I2 here. Okay, so if I write your IE1, so IE1 is your how much? Beta 1 plus 1 IB1, isn't it? Okay. Now similarly, if I want to write,
सर IE1 equals to IB2 नहीं होएगा यहाँ पे?
भी यहाँ पे बीटा है ना, कि आपका IC क्या होता है, IE क्या होता है, बीटा 1 प्लस IB होता है
सर नहीं, जो इक्वल लिखा हुआ है
ये वाला ना,
सर्किट में ऊपर देखो सर, ऊपर सर्किट में
ये IE1 है आपका,
हाँ जी,
IB2 क्या यहाँ पर, हाँ IB2. So now you have IE1 equals to beta 1 plus IB1. Okay, similarly if you want to write IE2, so IE2 will be what? IE2 will be your how much? Beta 2 plus 1 IB2, IB1 or IB2? IB2. Okay. Now if you want to write IB2, okay, so your IE1 is your, so what should I write here? I should write here beta 2 plus IE1. Okay, IB2 which is equal to IE1. So this will become your beta 2 plus 1. This will become your IE1. Okay, and you know what is the value of IE1. So this will become beta 1 plus 1. Okay, beta 2 plus 1, and this becomes your IB1. Now if you say beta is very high compared to 1, if you say if beta 1 is greater than 1, beta 2 is greater than 1, then of course you can write here also, you can write here beta 1, beta 2, IB1. Okay, so what happens when these transistors are in pair? Okay, so this get your gain get enhanced. Okay, so now you have current IB1 and you are getting the gain here beta 1 plus beta 2 gain. Okay, so your I2 is, so the emitter current of 1 becomes the base current of other transistor. So in this configuration you get coupled gain. Okay, so these are coupled transistor and these transistors always come together. Construction का ऐसे होता है, if you go market, if you buy, okay, they come combined, their packing is together, they're together packed. Okay, it's not like the two transistors you bring separately and connect. Okay, so the Darlington pair means they are coupled transistor and their packaging is such that they are connected, one emitter is connected to base of others. Okay, so let us do some problem based on this configuration. Last year one problem also came in exam based on this pair, so we'll do some problems. So this point is clear. Okay, any confusion here?
सर वो पॉइंट बता दीजिए, यूज क्यों होता है ये?
गेन बढ़ाने के लिए ना, गेन यहाँ अगर आप एक ट्रांजिस्टर लोगे तो उसका गेन आपको बीटा 1 मिलेगा, ओके, और यहाँ पे आपका IC क्या हो जाएगा, IC होगा आपका बीटा 1 IB, यहाँ पे IC क्या हो जाएगा आपका बीटा 1 into बीटा 2 IB1. Okay, if you calculate IC here, you say this is your IC2, okay, this is your IC1. So your IC1 is basically what? IC1 is equals to beta 1 IB1, okay, and your IC2, if you calculate here, that become beta 1 into beta 2 IB. So gain is high.
Okay, sir.
So let me solve some problem.
सर वन आई वांट टू आस्क सर, जो हमने VCC सप्लाई दी है, जो फर्स्ट वाले ट्रांजिस्टर में, मतलब इसको हमने कैसे, मतलब समझ नहीं आ रहा सर, एक बार थोड़ा
VCC दोनों को दिया है ना आपने, एक ही सोर्स से. अब if you can connect as number of transistor you want, अपने VCC कनेक्ट कर दिया यहाँ पर. अब ये VC इसको भी सप्लाई कर रहा है, इसको भी सप्लाई कर रहा है.
ओके सर.
ओके, बैटरी तो एक ही है, कनेक्ट हम एक बैटरी पे लाइक यू कैन कनेक्ट सो मेनी रेजिस्टर्स ना. सो ये भी डिवाइस है, आपने कनेक्ट कर दिया, VC कर दिया.
बेस का कनेक्शन, बेस का जो है वो किसके साथ है सर?
बेस कौन सा? ये वाला?
हाँ जी,
ये वाला बेस.
हाँ जी.
बेस तो वो सर्किट कंप्लीट सर्किट तो आगे रेजिस्टेंस हो गया आगे, ये तो बस ये खाली पेयर करने के लिए है. और कंप्लीट सर्किट में तो ये फिर आगे से रेजिस्टेंस होकर सब आएंगे, जो बाइसिंग उनकी वो अलग से होगी. ठीक है, ये पेयर है, पर रिलेशन हमेशा जो होगा सेम होगा रिलेशन. ओके, वो I1 कितना होगा सर्किट में, वो अलग से वहां वोल्टेज सोर्स अलग से जाएगा, यही जाएगा या दूसरा आएगा, कैसे भी आएगा, सोर्स में वो बैटरी लगा होगा I1 के लिए. ओके, बायसिंग अलग चीज है, पर ये एक पेयर है. ओके, जो सब साथ में लगेगा. क्वेश्चन देखते हो, उसमें आपका आ जाएगा सर्किट पूरा. So say I have okay, so say this is your one problem. I'm not removing this one. So say I'm connected with this one, and then you have some biasing here. Resistance are there. And I am connecting like voltage divider circuit here. Okay, this is a voltage divider. So you have resistance 10 kilo ohm, and then you have 20 kilo ohm. Okay, so in question they are asking beta 1 is given you 100, beta 1 is given 100, and beta 2 value is also given 100. Okay, so beta and beta may be same or they may be different also. They may be dissimilar transistors also. Okay, and let me ground this one also. Okay, and say this is my 60 ohm. Okay, so you need to calculate the value of IB1. Okay, in question they are asking calculate the value of IB1. Okay, so once you know the IB1, you can also calculate other things. Okay, so how should I proceed? So this is the voltage divide circuit. Okay, so what should I do? Tell me. Okay. So find IB1. तो अप्लाई करो, कैसे निकालेंगे?
सर अप्रोक्सीमेशन मेथड लगाएंगे.
Approximation जैसे भी करो. If you want approximation method, you can find approximation method. If you want to find आपका जो completely exact method है उससे भी कर सकते हो. Okay, so for the moment you do it for approximation method. Okay, so you just say this voltage is VB. Okay, so find IB1. Once you know the IB1, you can calculate what is your IE2. Okay, you can also calculate what is your IC2 automatically. Okay, so let us use, and VCC value is given in the question 15 volt. Okay, so VCC is given as a 15 volt. Now it is easy. Once you know the VCC, okay, this VCC coming here. Okay, so here you also VCC, and this voltage, this total voltage BC is dividing here because we are assuming is IB is 0. Okay, so you can find what is the voltage VB. So voltage VB will be your VCC, that is 15 upon 10 kilo ohm plus 20 kilo ohm into 20 kilo ohm. Okay, so this become your 15 upon 30 into 20. So this will come 5. So this comes as a 10 volt. Now you know this voltage is 10 volt. Okay, now you can solve this one, this circuit easily. Okay, you know this voltage. Okay, it's 10 volt. Put here. Now you can again solve the circuit here. You know this voltage here, and you can apply KCL and you can solve the circuit. So how can I write? Okay, if I say, okay, this is plus 10 volt, so I can write minus 10 volt. Okay, then say this is your VBE 1, and this is your VBE2. Okay, so I can write minus 10 plus VB1, okay, and then plus VBE2. Okay, then I want to write plus or minus. Okay, then here current is IE2. Okay, IE2 into what? Is 60 ohm or 60 kilo ohm? The question is given 60 ohm. Okay, this is equals to 0. Now you can write here VB, you can take 0.7. So this is 0.7, 0.7, total become 1.7, 1.4. Okay, IE2 you can take equal to what? IE2 equals to what? Beta 1 plus 1 into beta 2 plus 1, IB1 equals to 0. Okay, so minus 10 plus 1.4, and this will become 101 into 101, IB1 equals to 0, and this will give you IB1 value. Okay, this become 9.6 divided by 101 into 101. So tell me how much you're getting.
सर 60 भी आएगा
60 भी आएगा 60 ये रेजिस्टेंस में. ओके, I2 into 60 years. So 60 here. So how much is coming? How much you're getting? Tell me.
So 14 microampere.
14.3 or exactly 14?
14.05.
1.05 microampere. Okay. Or agar you neglect this one, okay, then you can write 100. That will come something 14 point something microampere. Now this is very simple circuit. बात कुछ नहीं, दो ट्रांजिस्टर है, लगाना तो हमेशा KVL ही आपको. ट्रांजिस्टर का ये खासियत है कि इसे सॉल्व करना बहुत आसान है. Okay. Now once you know the IB1, you can calculate what is your value of IE2, IC2. So IC2 will be simply beta 1 into beta 2 IB1. Okay, and IE2 will be simply beta 1 plus 1 beta 2 plus 1 IB1. So you can easily find out what is the current gain in the circuit. Okay, so this is the problem. Now let me solve one problem which came last year in exam. Okay, shall I raise this one? इसको मिटा रहा हूँ इसको. Let me raise this. Last year problem, let me check. So this problem came last year, that is 2022. Net. This time they have given you VCC equals to 12 volt. Okay. And they have given you resistance here. One IC resistance they have given here. Its value is 2 kilo ohm. Okay. One resistor is going here. Okay. That is value is 220 kilo ohm. Okay. And then one resistor here. That value is 580 ohm. Okay. So solve this, and the question what they are asking, they are asking, okay, they are connecting this circuit not from here, okay, they are connecting this circuit from here, this point, and here is resistance. This resistance value is 2 kilo ohm. Okay, beta 1 is given 20, beta 2 is also given 20. Okay, so they are asking what is the value of VC? What is the value? Find VC. Find VC in the circuit. Okay. Any other information you require to solve this one? Okay, so solve this one. 582 kilo ohm and 220 kilo ohm. So how do you solve? Or why? Let me simplify this further. Say this is 1 kilo ohm. Okay, VCC. Okay, say this is 1 kilo ohm. Now, can you tell me how to solve this problem? Basically, they are asking you what is the voltage here VC. So if you want voltage here VC, okay, then you should know what is current here, because here, see here voltage coming VCC. If you know the current here, you can know what is voltage drop here. So remaining voltage come here. Okay, so you should first calculate the current here. Okay, you should first calculate the current in the circuit. So say current in the circuit is how much? Okay. So how do you calculate current? So some current is going here, that is making your, just give me 1 minute more. How do you solve this current? IC. Oh, okay. So this is the transistor collector. So this current is IC1. This current is say IB1. Okay, and say this current is IC2. Okay. So if I say the current here is I. So what is the value of I? What is the value of I?
IC1 plus IC2.
Very good. IC1 plus IC2. So just what you want to calculate, you should know what is IC1 and what is IC2. Okay. So if you know IB1, you can find what is your IC1. Okay. So IC1 will be what? Beta 1, IB1. Okay. Similarly, if you want to know what is IC2, okay, you should know IC2, beta 2, IB2. Okay, and IB2 is equal to what? IE1, beta 2. Okay, that is equal to IE1, isn't it? And if you want IE1, then this will be what? Beta 1, beta 2. Okay, now that will be beta 2, and this will be beta 1 plus 1. IB1, okay. If you want to remove one, you can remove also, but I am calculating exact value. So you know beta 1 is given to you, okay. You find IB in the circuit. Find first IB1. Once you know IB, you know IC1. You know, then once you know this one, I2, you can calculate IC2 with this formula, okay. And once you know IC1, IC2, you will find I बताए तो ये ड्रॉप पता चल जाएगा, ये you will find voltage VC, okay. So, if this question is clear, question clear नहीं तो पूछेगा फिर से. I want the value of the voltage at this point. Okay, and if I want to calculate the voltage at this point, I just want to know what is the current in this resistor. Okay, current पता चल गया, तो I can multiply by this resistor. I know how much voltage drop is here from 12. Okay, so that will be my VC, and your I will be simply your here current is I coming, and that is getting divided here. IC1, IC2. So this I is IC1 plus IC2. Okay, IC1 will be this one, and IC2 will be this much. Okay, calculate and tell me what is coming values. So first let us calculate IB1. Okay, so calculate IB1 is simple. This is your coming 12 volt. Okay, so minus 12 volt plus 220 kilo ohm. Okay, IB1. Then you have VBE1. Okay, and then you have VBE2. Okay, I'm coming here like this, and then I have say IE2. IE2 is nothing. IE2 is your beta 1 plus 1, beta 2 plus 1. IB1 equals to 0. Okay, now this is 0.7. So I want IB1. So IB1 will be nothing. That will be 12 minus 1.4. Okay, this total 1.4 divided by how much? Divided by 220 kilo ohm.
सर एक रेजिस्टेंस भी आएगा ना ऊपर,
हमारे रेजिस्टेंस पे आएगा
580 ओम.
Okay, wait a minute. IB1 into 580 ohm. 580 ohm equals to 0. Okay, and then you have beta 1 plus beta 2, that is 21 into 21 into 580 ohm. Okay, this is the formula of IB1. So IB1 will be 12 minus 1.4, that will be 10.6. Okay, and then you have these values. Calculate, tell me what is the values coming for IB1.
25.6 microampere.
25.6 microampere. Okay, then you tell me now. Tell me what is the final current value I. So you know IB1, you can find IC1. So your IC1 will be simply 20 into 20.6 microampere. Okay, that is 10 to the power minus 6. You can convert in milliamperes. What is IC1 in milliampere? Once you know those IB1, you can also find IC2. Tell me total IC1 plus IC2. How much is coming? What is the value of I? In milliampere.
सर आई का वैल्यू 10.71 मिलियम्पेयर.
10.7 तो जाएगा 9.7. 9.7 should come. This is how much? Anyone else? What I have answer? 9.798. 9.798 milliampere. IC2 is this one. किसी का आ रहा है क्या? इसके आसपास भी आ रहा है क्या? 9% के आसपास कुछ So what is the value of IC1? Tell me. What is the value of IC1?
0.512.
How much?
0.1. 0.512.
512. Okay, milliampere.
Yes, sir.
10 to the power minus 3. Okay. Now this one.
Sir, आ रहा है
कितना आ रहा है?
9.812. 9.812.
Almost
9.812.
Okay, whatever. So I have this value 9.7 volt. Okay. So if this is coming, okay, you can find also this one. So beta 2 is again your 20. This is 21 into IV1. This is 20.6 milliampere. Okay, microampere. And you can solve this one also. Okay. So you have to sum this one. So I'm getting this 9 point this one. This is 20, 25.6. And here is 20, 21. So obviously this should come less than 0.5. Okay. So 0.5 से कम ही आएगा. तो 9.7 के आसपास से आना चाहिए. 9.7, 9.8 आना चाहिए. Okay. So once you know this voltage, okay, 9.7 volt. So you can easily calculate what is this voltage drop. So you can find the voltage drop here. VC will be nothing, simply VCC minus, you are saying this is I, okay, I into R. If I call this R, okay, so VCC minus I is my 9.790 milliampere and R is my 1 kilo ohm. Okay. So this cancel. This comes 12 minus 9.790, and if you subtract this one, this will come 2.20 volts. 02 volts. Okay, this is the answer for this problem. Okay. Any doubt? कुछ कंफ्यूजन है क्या इस क्वेश्चन में, डार्लिंगटन पेयर में? Okay, if there is no problem, I can switch to another problem. Okay, so let me read this one. So the answer is 2.202. ये क्वेश्चन लास्ट ईयर आया था. So this is the one kind of special circuit. Okay. Let us discuss some more circuits. The next circuit is your mirror circuits. What do you mean by mirror circuit? Okay, so you have this time also you have two transistors, but this time these two transistors are similar. Okay. Then you have one more transistor here. Okay. This is one terminal. Okay. This is one more terminal. Okay, and the two bases, okay, have common supply here. You have, this is your R, so this is your VCC, okay, resistance is there. Now these kind of circuits are called mirror circuits. Okay, why these called mirror circuits? Because in both the transistor, okay, same current flows. So IC, so say I say this is IC2, if I say this is IC1, okay. And if I call this is IB1, and if I call this IB2, okay. So now let's say this transistor is T1, say this transistor is T2. Now both transistors are similar, okay. Similar means now if I calculate the voltage drop here, so this is T1, so this is T2. If I calculate voltage drop here, VB, VBE, okay, base to emitter voltage. See, this is VB1, okay. In the this is the base, this is the emitter. See, this is VB2. VBE2. Okay. So because both the transistors are same, so same means इनका जो voltage drop होगा वो almost same होगा. Okay. So both transistors are similar. Both. Okay. Transistors T1 and T2 are exactly same or similar. Okay. Once you call them similar, their voltage drop will be same. Okay. Now just look at this point here. ये point VCC है. यहाँ पे drop हो रहा है. यहाँ पे कोई current flow कर रहा है IR. यहाँ से drop होकर यहाँ पे कुछ voltage आ रहा है. अब ये voltage same है दोनों के लिए. दोनों ट्रांजिस्टर के लिए वोल्टेज बेस पे देखो. दोनों ट्रांजिस्टर की बेस पे वोल्टेज सेम है. ये वोल्टेज जो सेम है, यहाँ से ये वोल्टेज आएगा, जो भी वोल्टेज बचेगा ये वोल्टेज यहाँ पे आएगा. ओके. वो हो जाएगा VB1 पे इधर, और यहाँ से जो वोल्टेज आएगा वो जाएगा VB1 पे. ओके. सो क्योंकि VBE1 और VB2 सेम है, तो ऑब्वियसली आपका IB1 भी IB2 के सेम होगा. ये पॉइंट क्लियर है क्या? एंड बिकॉज both transistors are similar, so their beta will be also same. Okay, so both the transistors are similar means their beta1 will be equals to beta2. Okay, and then VB base emitter voltage VB1 equals to VBE2, both will be same. Okay, so automatically when these are same, if I say cycle, look at cycle from here, यहाँ से इधर जाओ इधर जाओ इधर जाओ, सेम इसको सेम ही रेजिस्टेंस मिल रहा है, सेम ही वोल्टेज ड्रॉप मिल रहा है. यहाँ से इधर आओ और यहाँ से they get the same voltage drop here, so automatically their IB1 also same, so their IB1 is equals to IB2, and once IB1 and IB2 equal, okay, you can say their IC1 also equals to IC2. Okay, so same current is flowing in the both the circuits, that's why these are called your mirror circuits. Okay. Now here no power supply is connected. Okay, but this is just a way of representation. Basically this is also connected to VCC. We'll see in the problems. Okay, in some time in the problem they will give you like just like this. यहाँ पे आपको ऐसे दे देंगे, इसका मतलब नहीं है सप्लाई है, यहाँ पे सप्लाई है कैसे जुड़ा हुआ इंटरनल जुड़ा हुआ है. Okay, VCC से जुड़ा हुआ रहता है, but यहाँ पे पर्पस क्या है? the purpose is so we have to make mirror circuit. Okay, so if I want to flow, if I have a circuit and I want to flow same current in each transistor, okay, then I need this kind of configuration. So once this type their base are connected like this, okay, each transistor there will be same current will be flowing. Okay, there will be million of transistors, there will be 2 transistors, 3, 4, 10, 100. Okay, so that you can make like this mirror circuits. Okay, you can force to flow same current in each transistor if the transistors are similar. If you assume transistors are exactly same, then you can flow the same number, same current or equal current in all the transistors. So this is your basically mirror circuits. Now let me calculate what is the value of IB or IC. Any question?
सर लास्ट सर्किट में भी तो हमने कैलकुलेशन में VBE1 इक्वल्स टू VBE2 ही लिया है.
हाँ, पर उसमें बीटा1 कहाँ था? उसमें जो था
VBE1 और VBE2 की बात कर रहे हैं. वो हमने 0.7 ही लिया था.
वो तो सिलिकॉन है, तो सिलिकॉन 0.7 लेना ही पड़ेगा ना.
मतलब दोनों सेम. इसका VCE1 भी सेम होएगा.
इसमें करंट सेम होगा. ओके, उसमें करंट सेम नहीं था ना, उसमें IC1 IC2 सेम कहाँ था? उसमें एक में IC1 था आपका, बीटा1 IB1 था, और दूसरे में क्या था? IC2 क्या था? बीटा1 into बीटा2 IC2 था ना. And last problem when we are seeing there you having IC1 was equal to beta1 IB1, and next problem, last problem, your IC2 was almost equal to what? Beta1 into beta2 IB1. So IC2 बहुत ज्यादा था compared to, okay, यहाँ पर ज्यादा आपका IC1 IC2 भी सेम होगा. Okay, so now let me solve this circuit. Or suppose if you have this kind of circuit, okay, so the current flowing IR in the circuit, okay, IR, and this IR getting divided. Okay, so one current is going here. Okay, other remaining current is going here. So you can write your IR is basically your IC1 plus IB1 plus IB2. Okay. Now I am telling these are mirror circuits, so I can say IC1 equal to IC2 equal to IC. Okay. Similarly, IB1 equals to IB2 equals to IB. Okay. So now I have IR. This will be your IC, and this will be your IB plus IB. Okay. So IC will be your 2IB. Okay. Now your IR will be what? If you know IC you can write as a beta IB. Then you have 2IB. Okay. So from you can take IB common. This will become beta plus 2 IR. Okay. So if you want to calculate IB, so IB will be simply IR upon beta plus 2. Okay. And you want IC will be simply beta upon IR upon beta plus 2. Okay. So ऐसे क्वेश्चन में IC पूछता है जनरली IC क्या है, and if IC is if beta is greater than 1, if beta is very high to 1, in that case this beta cancel and you get almost IR. So जो भी करंट यहाँ फ्लो कर रहा है वो सेम करंट बाकी जितने भी टाइम से कनेक्टेड है इस कॉन्फ़िगरेशन में इस तरीके से सब में सेम ही जाएगा. ओके. सो लास्ट जो था, हाँ जो लास्ट था उसके अंदर इस तरह कनेक्शन नहीं था, यहाँ पे कनेक्टेड था. लास्ट वाले में तो बेस कनेक्टेड थे, ये कनेक्शन यहाँ पे नहीं था डार्लिंगटन पेयर में. अब ये कनेक्शन मेक श्योर कर रहा है कि यहाँ पे सेम वोल्टेज ड्रॉप हो, मतलब सी ये सर्किट सेम हो गया इनसे जल्दी सेम हो गया, इनका IB1 भी सेम हो गया. Any confusion? So if there is no doubt, okay, let us solve some problem based on this one. Okay. Now once you know this, just now I told you your IB will be simply what? IB will be your IR upon beta plus 2. And IC your beta plus IR beta plus 2. Okay. And now you want IR. IR कैसे निकालोगे? IR you can take any circuit. You can start from here. You take minus VCC plus IR into R, and then you can come here or you can go here. So that is simply VBE equals to 0. So your IR will be simply VCC minus VBE upon R. From this formula, you can calculate the IR value. Once you know the IR value, you can find IC, IP both. Okay. So that will be one problem. बोलिए.
IR वाला फॉर्मूला लिख.
किस वाला?
IR वाला.
IR तो अभी क्या मैंने VCC minus VBE upon resistance. VCC minus VBE upon वो तो केबल्स आ जाएगा जो भी सर्किट होगा था. So you have two transistors. One is say Q2, other is say Q1, and these transistors are connected here, and here I am coming with 5 kilo ohm. BCC is 30 volts, and this is current is coming here. It's connected here, and this terminal is here. So they say find what is the value of I naught. Okay, find the value of I naught. And VB is given, find I naught. VB is given 0.7 volt. Beta value is 100. Beta value is 100. Okay. Both the transistors are similar. So simple question है. Okay, अभी क्या ही था हमने? यहाँ दो ट्रांजिस्टर ही है. So ये IB1, IB2. Okay. So if I write the equation, okay. So this current is coming, say something I. Okay. So what I can write? I can write I equals to what? So this is your IR. Something is going here. Say I naught here. Because both are same circuits. So I can say if I naught flowing here, I naught will be also flowing here. Okay. So say the remaining current is coming here. Say this is I, and this I will be what? This I will be what? IR. So IR will be equals to your I naught plus this current is
IB1 plus IB2.
so 2IB. Okay. So I naught is coming here. This current is coming here, and rest current is going here, and this rest current is dividing here. So I can write this I2 plus 2IB. Okay. Because the formula same ही बन जाएगा. And I naught is what? Collector current for this transistor. That will be what? Beta IB plus IB. So IB will be your 2 beta plus 2 IR. Okay. So IB will be again IR upon beta plus 2. IR you can calculate from this formula. So IR will be your BCC 30 minus 0.7 upon 5 kilo ohm. 30 minus 0.79, okay, 19.3, okay, upon 5 kilo ohm. Tell me how much IR is coming. This should come 5.86 milliampere. Coming, check it. IR.
Yes, sir.
Okay. So in the question they are asking what is the value of I naught. Okay. They are asking what is the value of I naught. So I naught is very simple. If I naught is nothing, I naught is your what? Beta upon beta plus 2 into IR. Because I naught is equals to beta IB, and IB is equals to IR upon beta plus 2. Okay. So I naught can be what? Beta is 100 upon 102. IR already I have done 5.86 milliampere. Okay. So this will give me the current value 5.745 milliampere. Okay. That is like the same, almost same. Okay, because this ratio here is almost 1. So there is a same. So whatever current you are flowing in resistance IR, same current is flowing here. But IB, general IB, you know, IB is microampere. So milliampere current is coming here. Out of milliampere, some microampere current is getting divided here. That is negligible. So always this current I naught will be same. So its IB2 is same, I2 IB2 same. Automatically this two current will be also same because they have same beta. Okay, these signs have a same beta. So automatically the collector current will be same. So that is your mirror circuit. Any confusion? Okay. So let me give you one homework based on the same problem. This is in 100 ohm. Okay. Here you have 5-volt battery is connected here. Then say here current is dividing, say IB, and say this is also connected here. So same VB, this is VB. Okay, so here also same VB, and this is connected also here. So you need to find the value of IR. Okay, what is the value of IR? Find IR.
100 किलो ओम है, 100 ओम है,
100 ohm है. Okay, 100 ohm ही है. So this is a find value of IR and find the value of IC. IC of this transistor. Okay, so this is IC. Here, this is emitter, and this is IC here, and this is IR. So find IR, IC. I'm giving the value also. You have to send the homework to me. Okay. So your IC plus IR is almost equal to 43 milliampere. Okay. So this is your homework.
Beta. Beta.
बीटा क्वेश्चन में दे रखा है, बीटा की जरूरत नहीं पड़ेगी. ओके, टू टेक बीटा इज ग्रेटर देन 1, तो कैंसिल हो जाएगा अपने आप.
so VB
VB 0.7, VB is 0.7.
सर आईसी यहीं पे आएगा?
आईसी क्या भाई, ये वोल्टेज बैटरी लगा दिया, ठीक है. अब यहाँ पे आईसी फ्लो कर रहा है, यहाँ आईआर फ्लो कर रहा है, ठीक है. अब ये आईआर डिवाइड होगा कहाँ पे, 2 आईबी में प्लस आईसी में. ये भी आईसी है, ये आईसी, ये तो आईबी है, सॉरी ये तो आईबी है, करेक्ट. तो ये आईआर आ रहा है, दैट इज डिवाइडिंग द आईटी आईसी. ओके, सो यू कैन यूज सेम इक्वेशन, आईआर इक्वल्स टू आईसी प्लस 2 आईबी, and this IC and this ICC. Because gain is same, gain is very high. In that case, you can assume that IB is negligible. Okay, compared to here. यहाँ से करंट आ रहा है, कुछ करंट आ रहा है, और यहाँ डिवाइड होगा दोनों में. ओके, ये मान लो ये ऑलमोस्ट IC इक्वल है, थोड़ा ज्यादा है, उसमें से कुछ करंट यहाँ चला गया तो बचा हुआ IC, that is same, equal to almost same here. So here now, तो अभी मैंने 2 किया है, जरूरी 2 ही करें, आप ज्यादा भी कर सकते हो. So this is same. Okay. This transistor. Beta is 100 for each transistor. Question में you can take VB is 0.7. Okay, and here I am taking the VCC here, say 6 volt. Okay, and its resistance, say connected resistance here. This is your 1.2 kilo. Okay, so this current is flowing, say IR, and this is again grounded. Okay. So now you need to find again the value of this I. What is the value of this I? That means IC is asking what IC. And यहाँ से disconnected here और ये यहाँ पर ऐसे connected. That means common ही है. Common point ही है. Okay. So now tell me, how will you approach this problem? So I have 3 transistors. Say this is T1, T2, T3. बीटा सबका सेम ही है, तो यहाँ से करंट IR आ रहा है. ओके, वो IR यहाँ पे चला जा रहा है एक तो. ओके,
IR is equal to
और यहाँ पे IB1 जा रहा है, एक IB यहाँ जा रहा है, एक IB यहाँ जा रहा है, एक IB यहाँ जा रहा है. ओके, ये टोटल करंट तो IR जा रहा है जैसे पहले आ रहा था. आपकी डिवाइड क्या हो रहा है, 2 की जगह 3 में डिवाइड हो रहा है, यहाँ पे डिवाइड हो रहा है, और फिर यहाँ पे 3 IB. So you can write your IR if you apply node analysis here. Okay, so if you node analysis, you can write IR equals to your I plus 3 IB.
3 IB.
Okay, तो इससे आपका IB निकल जाएगा. And you know I is nothing, beta IB plus 3 IB. Okay, so this will become your beta plus 3 IB this time, IR. So you can find IBR, okay, equals to IR upon beta plus 3. IR you can calculate from this formula. Okay, so IR कितना हो जाएगा आपका? VCC 6 minus, you come anywhere here, 0.7 upon 1.2 kilo ohm. That is 6 minus 0.7 is become how much? 5.3 upon 1.2 into 10 raised to power 3. Okay, how much is coming IR? Tell me. How much coming IR?
4.41.
4.41 or 42 milliampere say. Okay, so once you know this IR, you can find your I is nothing, beta upon beta plus 3. Okay, because your I is what? I is simply your beta IB. Okay, beta IB, sorry, what is your I? Yes, beta IB. Okay, and IB is your IR, so beta upon beta plus 3 into IR. So you know the IR, you know the value of beta, so 100 upon 100, 103 into IR is your 4.42 milliampere. Okay, and if you solve this one, slightly less than 4.42 will come. Okay, so the answer is given to me is 4.29 milliampere. Any doubt for this problem? Okay. So these were 2 circuits. We'll see some other circuits tomorrow. Okay. So अभी आज को doubt है तो पूछ लो. So I'm stopping here. Thank you.